Our next session is titled ADOT Silo Connection Case Study from the Performance Controlled System, PeCoS, as it's known, to GIS Boundaries. Our two speakers are Shaun Perfect and Carol Francis. Shaun is a senior geospatial analyst with the Arizona Department of Transportation. He's been a GIS professional for over 7 years, with a majority of that time within transportation GIS. He has a bachelor's degree in geography and urban planning with a certificate in GIS from Arizona State University. Shaun is currently maintaining ADOT's linear referencing system, or LRS, as well as coordinating with other groups to integrate non-GIS data into roads and highways. He has a strong history of GIS roadway characteristics, data analysis, and editing. Carol is a senior GIS analyst herself with GISTIC Research. At GISTIC, Carol works on projects related to analyzing and visualizing transportation data. Carol has created numerous Tableau and Esri dashboards and developed FME processes that generate highway log products and a process that creates polygonal boundaries from non-spatial event data. Carol has a master's degree of science in GIS from the University of Arizona. Please help me welcome both Shaun and Carol to their presentation today.
Thank you, Robert. As Bob said, my name is Shaun, and I work closely with Carol on this project specifically. Carol, do you?
Yeah. Hi, everybody. Robert, thanks for introducing us. And I developed the process that we'll be talking about today.
So just getting into it, basically we'll be talking about how we took our PeCoS system, which is managed by the maintenance group here at ADOT, and converted them into GIS boundaries. So some objectives with this project, we wanted to automate the translation of the non-spatial PeCoS maintenance and engineering boundary definitions into a GIS layer, which we definitely support through our roads and highways integration. And within that, we wanted to support some data visualization for dashboarding and mapping, which Sage and John just went through. One of the more important things in this is we wanted to connect the correct data silos, in that Sage had mentioned in the past presentation that we deal a lot with data governance, and we want to make sure that we are getting the data from the direct source, and that we're not taking a copy of anything or anything like that, and we want the main data. In doing this, we have developed some quality control, some QC analysis that we use to relate back to maintenance and also on our side. Some PeCoS history. I know you're looking at the word PeCoS and I'm wondering if a kindergarten wrote that. But no, it makes sense. It stands for the Performance Controlled System. Has been used by ADOT for 40 years and has helped maintenance managers develop and carry out maintenance programs with planning, organizing, and controlling maintenance work. The main thing we want to say out of this is PeCoS only contains tabular data. It isn't GIS enabled, and that is the main basis of why we wanted to do this project, to get it in the GIS so that we can use it within mapping and relate it to our other data. So with the maintenance crew, their specific names, we call it TSMO, it's Transportation Systems Management and Operations. Again, they deal with just the tabular data, and they use that data to send out their crews onto the field. Basically, that tabular data includes location information such as mileposts, routing, and anything else specific to the maintenance crews. So the correlation with these tabular maintenance records and GIS is that we host these layers within our roads and highways. As I said before, the roads and highways includes multiple layers of ADOT information, including pavement, traffic, functional classification, a lot of those ideas that Sage and John went through with their story maps. So we have all this data in the same roads and highways database, so we can integrate and overlay those data sources together, producing maps and dashboards for upper management. So we're talking about 3 of these layers. 2 of them are polygon boundary, the maintenance unit polygon, which shouldn't be confused with the engineering district. Now, the engineering district is broken up to 5 districts throughout the whole state, and the maintenance districts are within each one of those different districts. The MMS, Maintenance Management System, is a linear routing event based totally upon the PeCoS tabular data. It actually fits right onto our roadway network, also called AGIC, and it allows us to overlay all the different events within roads and highways onto this linear routing event with maintenance. So basically, what we did before was we took a boundary change that was given to us by an email that upper management sent, who was ever in charge of the maintenance districts at the time and the boundaries. They gave us a milepost, and basically from point A to point B where it changed based upon the route and milepost information. And so we took that and we manually went into the roads and highways database and changed it. Now, on occasion, there were more than a few, and it was kind of a tedious task and time consuming, to say the least. So basically, we wanted to think above and beyond how we can get rid of this manual process and build it into more an automated process. So some of the benefits to ADOT included in this automated process. It gives ADOT's GIS data up-to-date validation. The automation, like I said, saves time and eliminated manual efforts. It reduces future errors and assists in collaboration efforts between ADOT groups. In this instance, MPD GIS, which is us, and maintenance. In other examples, one of the big pushes that we're doing now is teaming up with different groups within ADOT and some of different state organizations, and collaborating if they have tabular data to integrate that into GIS if it makes sense. Say, for instance, if they have any location data whatsoever, we want to bring that into ADOT in our GIS and be able to overlay that with a lot of other events. Giving, answering any questions, for instance, like pavement, we're teaming up with them to be able to maybe take these boundaries, these district boundaries and engineering boundaries, and provide some output. Say there's so many miles of good pavement within the Southwest District. And so we can put those up on the dashboards like John and Sage were referring to. It helps identify errors within PeCoS boundary definitions. So a big thing that we got out of this was as we were going through the data and doing these automated processes, we found some errors within PeCoS that we could fix, and we relate that back to the maintenance crews and the maintenance group. As well as it found errors on our side as well that we could fix up. So it was a win-win situation for all of us. And now I'll turn it over to Carol because she's the brains of this whole project. And so take it away, Carol.
Thank you, Shaun. So in the early days of this project, I thought it all seemed completely bonkers. How in the world was I supposed to create polygons from a non-spatial CSV? I felt like I was being asked to convert lead into gold. So I spent quite a bit of time researching. First, I needed to understand what the PeCoS data represented. You're all familiar with milepost signs that you see when driving down the freeway. Well, the PeCoS data table is basically a record of which roads each crew maintains, where the statewide road network is broken down into milepost ranges on each highway. Once I was able to relate this table to what I see when I drive down the freeway, I use standard geocoding tools created by GIS and ADOT to convert the milepost ranges in the table to spatial geometry. Geocoding route segments is very similar to geocoding addresses, except we're assigning spatial location to bits of roadway instead of buildings. Well, now I had lines. How in the world was I supposed to draw polygons around these lines? Buffers, the obvious choice, just made a big mess. So I took the next obvious step and asked the hive mind on social media. This was actually a stroke of brilliance. Somebody suggested Thiessen polygons, which was critical to solving this problem. I built this process in FME. If you're not familiar with FME, it's a software package that's similar to Esri's data interoperability extension. And before I dive into the meat of this process, I'd like to talk about my favorite FME transformer, the Voronoi diagrammer. My apologies to Mr. Voronoi for mispronouncing his name. I have looked it up on YouTube and I'm trying. I'm really trying to say it correctly. Voronoi diagrams are a type of Thiessen polygon. The Voronoi transformer is really cool. If you have a point data set, it draws polygons around each individual point. Every location within each polygon is closer to the point contained within that polygon than any other point in the workspace. This transformer is what allows us to draw polygon boundaries around our events. A screenshot of the non-spatial PeCoS table is on the left. This table refers to routes and milepost ranges that are maintained by specific road crews. The beginning and ending columns in this table refer to the beginning and ending mileposts on a route that are maintained by a specific maintenance unit. The desired linear and polygonal output is on the right, which is a spatial representation of the same linearly referenced events. This flowchart summarizes the FME polygonization process. There are two data inputs for this process, the route data set from the Roads and Highways database and the non-spatial maintenance event table from the PeCoS database. We first geocode the non-spatial maintenance event table to obtain event geometry. Once we have linear geometry, we split the lines into points because the Voronoi diagrammer requires point input. Then finally, the Voronoi diagrammer generates polygons around the points. I would also like to point out again that at many steps of this process, we log data bugs, which are automatically emailed to the appropriate recipient in Excel spreadsheets. Now let's take a look at the data as it goes through the FME process. These three screenshots were taken from critical intermediate outputs within the FME process. Each screenshot illustrates the same intersection, where I-10 intersects State Route 202 South Mountain on the Phoenix-Chandler border in Maricopa County. The screenshot on the left shows the linear output of the geocoder. The center screenshot shows the point output of the chopper, which is a transformer we use to extract the vertices on the lines, thus converting the lines to points. We then feed these points into the Voronoi diagrammer, which generates polygons around each point. These polygons look pretty crazy, but when we dissolve and aggregate these spiderweb looking polygons on maintenance units and their parent engineering districts, we get beautiful polygonal boundaries. As Shaun mentioned, this is an automated process that has removed many human factors from the connection between the PeCoS and the Roads and Highways data silos. Furthermore, the FME output table is temporal and retains a history of previous linear events and polygons. This is significant because the PeCoS database is not temporal, Now, the MPD team at ADOT has a spatial and temporal history of maintenance boundaries to accompany the spatiotemporal roads and highways database. Now let's take a look at the process output. First, we see the spatial linear output of the process. Next, we see the polygonal maintenance unit output. The Voronoi process drew these polygons around the lines. Finally, we see the engineering district output, which is an aggregation of their child maintenance units. As we have mentioned several times previously, this process also has many data validation and QC steps baked in. On the next few slides, I will show examples of data bugs that we have found using the polygonization process. As I examined the process output, I found something that I thought was really interesting. There were a lot of little bugs in the non-spatial PeCoS table that may have existed for years. However, since the PeCoS table is not temporal, we really don't know the time extent of these data bugs. It's pretty hard for humans to digest tabular data, and the road crews didn't realize the table didn't quite match what they were doing out in the field. When we drew polygons around the non-spatial events, we found anomalies like this one in engineering district polygon output. In this instance, there was a small area of the state that was attributed to the central district, yet far away from the main body of the central district. This visual output allowed us to find that a road segment within the outlying central polygon was incorrectly assigned. This has since been fixed, and I added a QC check in FME that identifies these tiny disconnected polygons. This is a similar issue to the previous slide, but this represents a new bug that recently appeared in the source data. In the maintenance unit polygons, there is a tiny area of roadway that is attributed to the Selectman maintenance unit in the PeCoS database that is far away from the main body of the Selectman maintenance unit polygon. This exception is currently in review by the ADOT team. This jagged boundary between maintenance units was caused by a discrepancy in the PeCoS database that indicated a small section of frontage road on Interstate 8 was being maintained by a different maintenance unit than the corresponding mainline roadway. When the Voronoi diagrammer drew polygons around these areas, it resulted in a jagged boundary. On the ground, the frontage road and the mainline in this area are maintained by the same maintenance unit. The PeCoS database has been updated to reflect this reality, and the polygonal boundary output is no longer jagged. In conclusion, ADOT has historically used the non-spatial PeCoS database to track which roads are maintained by which maintenance units. However, this database is not part of the spatiotemporal roads and highways database and has been difficult to incorporate into GIS analyses. We used FME to spin some GIS alchemy and created polygons from a non-spatial LRS event table, which also identifies data quality issues and creates a temporal history of the linear and polygonal maintenance events. And thank you for joining us today. And at this point, I'd like to open the floor to discussion and questions. And please feel free to reach out to either of us at any time.
Well, thanks, Shaun and Carol. We do have a couple questions for you. The first one I think was asked early on, but Carol, I think you did a good job describing the process, but I'll still go through it if you want to highlight the key points to it. Is the question is, with non-GIS data, only tabular, are you georeferencing to get the GIS data or what?
Yes, that's exactly, we georeference. So we have, for every maintenance boundary, we have a description that is the route and the milepost range that maintenance boundary it covers. And so we then use a geocoder that was developed by a GIS engineer at ADOT. And it's fabulous. We input, we actually have to do a little conversion in FME before we can use it. The PeCoS table represents milepost ranges, and then the GIS route data that we use actually displays route measure. And so we have to do a little switcheroo to convert from milepost range to route measure. And then we put it into this geocoder and it spits out wonderful lines. Yes.
Yes. I agree that with ADOT, that geocoder, since ADOT, just a little background, I'll kick in as an ADOT employee, is that everybody references route and milepost in ADOT. Nobody knows about linear measure or anything like that, or XY coordinates or lat long. But if you say you're on I-17 at milepost 299, all your ADOT highway maintenance people and your engineers know you're right next to State Route 179 going up to Sedona. So that's a key thing for ADOT is route and milepost. Our next question, I think you also talked about too, is they're asking, how do you find all those inconsistent lines and such?
So part of it was manual. In the early days of this process, we got some really strange looking polygons. So those were easy to just identify. But then once we fixed the big issues, I basically developed a process that aggregates all these polygons and then I deaggregate it. And when there's a tiny polygon, it spits it out as an error message because they should all be contiguous. And, you know, there shouldn't be a big polygon with one maintenance boundary and then a tiny polygon from the same maintenance boundary. So that actually makes it pretty easy to identify. Yeah.
Okay. Well, thank you guys. That's all I have for questions, unless somebody types up something in the next few moments or so. If there's anything else that you wanted to elaborate on or talk about, feel free. We've got a few extra minutes. Otherwise, we'll wrap up this chat. We'll let the session run for the next few minutes in case somebody has any last moment questions or wishes to talk to either of you in chat. I want to thank Shaun because I have to do this, Shaun. I'm sorry, but you gave a perfect presentation, Shaun. It was a Shaun Perfect presentation. And Carol, wonderful as always listening to you describe the work you do and what a great job you guys do at GISTIC. Thanks again.
You know what, Bob, it wasn't that perfect because I caught myself in a little lie. I mentioned 5 engineering districts and it's actually 7. So sorry about that.
That's
okay. Few people would have caught you on that.
I didn't catch you, Shaun, and I'm the one who drew the polygon. So
you could 22, 21, whatever it takes. And just to add on to Robert's there, thank you guys all for presenting. That was quite wonderful. And I just wanted to remind all the attendees, there is a small little survey. If you would take that, it should be on the right side of your page. It's very brief. If you could fill that out after this session, it'd be much appreciated. So I did see one other question while we're at it. I don't know if you saw this one, Robert. It said, did you create all the tools or workflows for that FME data or whatever toolbox stuff?
Yes and no. So the Voronoi diagrammer is built into FME. That comes standard. The geocoders, we use a combination of geocoders. One is developed by GISTIC and one is developed by ADOT. So we need to use both because one converts between milepost and route measure, and the other one actually assigns spatial significance to a non-spatial event. And then the rest of it is just doing manipulations of the process flow so that the different tools will work.
That makes a lot of sense. I hope that answered the question. So you take kind of basic off-the-shelf tools and manipulate them the way you need them to work.
Yes, for the most part, yes.
Well,
anything else you want to add, Robert?
What's that?
Anything else you'd like to add? I'll let you
conclude.
I
apologize. I saw that question earlier and then it disappeared, so I thought it had gotten withdrawn. I apologize.
No, do not apologize. That happened to me in an earlier session. I don't know where it goes. We'll just, it's the virtual gremlins.
I guess so. I think Sage is, bringing her gremlins to us because having worked with her all the time, she always seems to find the gremlins in the computer. So,
oh my goodness.
So if I have to blame anybody, I'll have to blame it on her today. But thanks everybody for showing up. We hope you enjoyed the last hour here talking about different things, specifically that ADOT does in managing data and more importantly, visualizing data. It was a heck of a great presentation by both teams on how story maps and how polygons and just everything that we do helps. And it's great seeing these things come alive at ADOT, because it's opened the eyes of not only the men and women that are down in the trenches doing the work out on the roads, but also middle management and upper management are all of a sudden getting an eyes wide open look at things they've never seen before. So thanks again, everybody.
Yes, thanks again, Sage and John and Shaun and Carol, and all the attendees. If you'd like to reach out to these presenters, you can find them on the main home webpage. They're in the community. Just type in their names and you can message them individually. So thank you very much.